A person plans to invest 3 times as much in a Turner small cap growth account at 10.4% annual interest as in a Merrill Lynch small cap growth one account at 12.2% annual interest. How much should the person invest in each account in accounts to earn a total of $217 in 1 year? Alright, so why don't we begin by coming up with an equation that describes the situation. So you got some money, it doesn't describe for you how much money, it's just saying any amount, whatever amount of money you're going to invest. And you're going to put some of it at the 10.4% interest rate and some of it at the 12.2 annual interest rate. And you've decided that you want to put 3 times as much into the Turner account, the small cap 10.4%, as you do into the 12.2%. Right? So you've already decided you want to play it a little safer by putting the majority of your money into the 10.4% and then a smaller amount of your money into the 12.2%. And you've chosen to make it a 3-to-1 ratio. So you want to invest 3 times as much into the Turner account as you do the small cap account. So interest rates. So let's figure out how to come up with an equation that describes the total amount of interest earned as a function of the amount of money you invest in these numbers. So remember that the overarching formula for interest is that interest earned is equal to the amount of money invested times the rate of return, I'll say interest rate, times time. Right? That's how you get your interest earned. Interest earned is equal to the amount of money invested times the interest rate times time. Now, this formula can get a little bit complicated if you do some, crazy stuff. So the units have to match. In particular, here is where things can get a little crazy because the interest rate could be given in a variety of ways. Maybe they decide to give it to you in the form of returns, 5% per week. You get a return of 5% per week. Well, then that means that the time frame over here has to match. You have to put it in terms of weeks. I'm going to invest at 5% per week for 7 weeks. Okay, that works. You can't put a rate of return of 5% per week and multiply it by years, right? You have to convert the years into weeks so that you can have these 2 units match. If this is given to you as a rate of return on a daily basis, right? A certain interest per day, right? Per day, then this time frame has to also be in matching terms of days. So they have to match. Now, luckily for us, right now, this isn't where we focus our attention. They make this part really easy. For us, in this entire chapter, time is always 1 year in all of these questions. And the rate of return is always given as, in terms of years, annual interest rates. So, per year. So for us, these 2 things always match. But just keep in mind that down the road, there might be other kinds of word problems where they, give you tricky things here to figure out what the interest rate is. They did that in this book to make it per year because that's the way you'll almost always run into it in the real world anyway. As you can imagine, banks can be shady. So there was a time when they would trick people by giving the interest rates in a variety of ways. So, what's better, getting 5% per year or getting 8% per 10 years? Okay, so if you think about it, getting the 5% per year is better than getting the 8% per 10 years. But you put the 8 nice and big, advertising focuses on the biggest number. You can do some shady stuff and trick people into thinking that, they're getting a different result than they really are. So as one of the ways that the government steps in to try and make sure that people don't get cheated, they've standardized it. They've made it a requirement for all banks to state their returns and all their stuff on an annual basis. And it makes it easy for consumers to shop between banks and compare them and know what they're getting. So that's why almost everything that you run into is based on an annual basis here. So that's what most of these problems are. So for us, this is a simple equation. It's 1 year, and then this rate is given per year. So these two things match. And in fact, since it's 1 year, you know, you can put a 1 there, or you can just ignore it, and everything would be okay. Okay, so keeping that in mind, let's go back to this thing. In this particular situation, the total interest earned, total interest, for us is going to be equal to the interest earned from the Turner account plus the interest earned from the Merrill account. Right? Figure out how much money you're going to make out of this account. You're going to invest some money into that account. Figure out how much money you're going to make into, from this account. Add them together. That'll give you your total interest earned for the year. Right? This is a time period of 1 year. So in the 1 year, well, that's this thing right here. So the Turner account, well, that one is earning 0.104, 10.4%. That's the rate. The time frame, well, it's 1 year, right? Like I said, you could just put a times 1 there or just ignore it. And then we need the amount of money invested. I don't know how much money this is. So this is where you would put just, you know, an unknown variable we have to determine, right? Some amount of money, X, is being multiplied by 0.104 times 1, and that'll give you how much it is, right? What about Merrill? Well, same thing. This is 0.122 times 1. And we don't know how much we're investing, so let's just put a y in there for now. And this is what we have here, so I'll put total interest. Okay, so we have an equation for it, except we have too many unknowns, right? This is obviously an unknown. We're trying to figure this out. This is an unknown, and this is unknown. 3 unknowns, that's too many unknowns. So we want to try and reduce the number of unknowns, in particular, these two. We don't need 2 different variables to represent these quantities, but because there's a connection between them, right? And the connection is that we initially decided that we want to invest 3 times as much into the Turner account as we do into the Merrill account. So there's a connection between these 2 things, right? Okay, so keep this in mind. Which one should be bigger? The X or the Y? When you read that. A person plans to invest 3 times as much into the Turner account as they do the Merrill account. So which one should be bigger? The X one, right? Whatever answer I get, this one should be bigger. This X represents the amount of money invested into the Turner. This Y represents the amount of money invested into the Merrill. One possible answer that is consistent with the idea they want to invest 3 times as much into the Merrill, it could be that maybe we invest 300 into here, which means we invest 100 into there. 100, this one's 3 times bigger than that one, right? Or maybe it's 3,000 into here and 1,000 into there, right? But whatever it is, X is definitely bigger than Y, right? So let me put that over there. So we have that X is definitely bigger than Y, right? This one's the bigger one. Big, small, like that. Okay, so now keeping that in mind, which would be a true statement? To say 3x is equal to y, or to say that x is equal to 3y? 2 options, very confusing for people. Which one should we use? Number 1 or number 2? 2? Anybody think it's number 1?
Wait, what's the second question?
Remember the statement. A person plans to invest 3 times as much into the Turner account as they do the Merrill account. So which statement is true? This one's really confusing, right? This is one of the most confusing ideas in word problems. People often get this part of it wrong. So try and remember this idea over here. Which one should be bigger, right? So the X one should be bigger. Okay, so x is bigger, y is smaller. So should I take the one that was already bigger and triple it and make it equal to the little one?
No.
Oh.
That doesn't make sense, right? So this one is wrong. This one is right. I want to take the little one, the small one, triple that one, and if I triple the little one, that one is equal to the big one. That's one way to think about it. Okay? So that's the statement we want to use. X is equal to 3 times y. The big one is equal to 3 times the little one. Right? If these were the numbers, 3,000 and 1,000, I triple the little one and it makes it equal to the big one. Okay, so now that I have this additional formula, that x is equal to 3 times y, well then I can go over here and replace the x with 3 y's. 3y times 0.104, I don't need the times 1, plus y times 0.122. I could have also chosen to divide both sides by 3. So another statement that is also true is that 1/3 x is equal to y. Another thing that's true. Right? Take the big number, divide it by 3, it should be equal to the little number. 1/3 x equals to y. So if you want to use that formula, we can replace this y by 1/3 x, and then we'd have nothing but x's in it, so we can have a function of x. But in this case, the advantage of this case is now we don't have any fractions, right? If I had done that, I'd have a third here. Here I don't have any fractions. I don't know, I like that better. But ultimately I'm going to have to divide that by a 3. If I did that, decimals, you know, ultimately it doesn't really matter. Okay, so I'm going to multiply this by 3. And what do we get? 31.2?
Yeah.
0.312y plus y 0.122. Right, this is all equal to total interest. And then finally I can combine those two things together. I have 0.312y plus 0.122y. So they're like terms, and what do they equal? 0.434y. Right? Okay, so what I'm going to do is that this whole thing equals total interest. So I'm just going to define this as g of y, where g of y is equal to total interest. The total interest as a function of y, and keep in mind that y was equal to the amount of money we invest into Merrill. Good? Y is the amount of money we invest into Merrill, whereas x was the amount of money we invest into Turner. Good? Questions? Okay, so let's explore this guy a little bit. Let's put a table going over here. So we had g of y, which is equal to the total interest earned, is equal to 0.434y. So let's create a table with some values. Y there. So let's say we put 0 there. Then what happens here? G of 0 equals to 0.434 times 0. So we just get 0. What does this mean? This is the ordered pair 0, 0, where we have y and g of y. What kind of a sentence can you make up for this? If you invest nothing into the Merrill account, which means that you invested nothing into the Turner account, because you invest 3 times as much into the Turner, so you invest nothing into either the Merrill or the Turner, and you made nothing. That made sense. All right, let's put 1 into here. So if we put 1 into there, we get g of 1, which is equal to 0.434 times 1, which is 0.434. Okay, so we get 1 comma 0.434. All right, well, I'm going to round this final answer to 0.43. I'm going to just round it to 43. Why did I do that? This represents 43%. G of y was the total interest earned. So this represents how much money you made in interest, which would be 43 pennies, right? This represents pennies. And with money, we like to round to the nearest penny. Okay, so it's 43 pennies. So what's the full sentence for this? If you invest $1 into the Merrill, right? Remember, Y is the amount of money you invest into Merrill. If you invest $1 into Merrill and therefore invest $3 into Turner, right? Because we always keep in mind, this has baked into this formula that the other account is going to be 3 times as much. Where X was the Turner at 10.4% return, and the Y was the Merrill at 12.2% return. So if we invest $0 into here, then that means we invest $0 into there. If we invest $1 into Merrill, that means we invested $3 into Turner, right? Because we invest 3 times as much. So in this situation, we really have a total investment of $4. We invested $1 into Merrill, $3 into Turner, a total of $4 invested, and I'm going to make 43 pennies in interest for the entire year. Does that sound like a good investment? No? No big deal? Does it seem like a waste of your time? All right, well, how about if we made it $1 million?
Oh. So why would you do that?
Why would you do that? Because you're rich and you can. Right? These kinds of things seem kind of silly for poor people. Like, really? Go through all that trouble just to invest a little bit of money and get a little bit of interest? But if you expand that out to lots of money, this is a great deal for people. So if they invest $1 million, this would be G of 1, 2, 3, 1, 2, 3 equal to 0.434 times 1, 2, 3, 1, 2, 3. And what do we get as an answer?
$434,000.
$434,000. It's not bad. So if we invest $1 million into the Merrill account and $3 million into the Turner account earning 10.4% annual interest, and the Merrill account earning 12.2% annual interest, your total interest earned for the year would be $434,000. It's not bad. It's a pretty good salary, right? Would you like to have a job where you earned $434,000 a year? Okay, well all you have to do is have $4 million in the bank. And then you go golf and hang out. Cool? There you go. That's all it takes. Just be rich and then you can make a lot of money and then people will think you're a great businessman. Look at you, making all that money out on the golf course. Making those great business decisions. Right? Okay, so back to this question now. This question said, how much should you invest for your total interest earned to be $217? Okay, so we want to figure out this. We want an answer of $217. We want this to be the answer. So how much should we invest into each of these 2 accounts in order for your total interest earned to be $217? Okay, so obviously we have to set it equal to this. Right, so let me put it over here. So I want to find y such that g of y equals to $217. That's what we wanted. Okay. And g of y was 0.434 y equals to 217. So if we divide both sides, we get y is equal to 217 divided by 0.434. 500? Okay, so we get y equals to 500. Okay, so if y equals to 500, then x must be equal to 1,500. Right? Remember, x was the amount of money invested into the Turner account, and we said we're investing 3 times as much into the Turner as we are the Merrill account. So this would be a total investment of $2,000, where 500 is invested into the Merrill account and 1,500 is invested into the Turner account. The Merrill account earning 12.2% interest, the Turner account earning 10.4% interest, and if you set that up, that will result in $217 in interest. Questions? So 217, not that great, right? I mean, it's a good return on your investment of $2,000, but you really can't live on $217, right? What is the smallest amount of money that you think you can live off of? Like, let's say you want to retire, you have some money in the bank, you're just going to be living off the interest. What's the smallest amount of money you can have there in order to live off something? So think about what is the monthly income that you would have, that we'd have to have in order to retire. Right now. Quit school, quit your jobs, just hang out and chill the rest of your lives. How much does that monthly paycheck have to be? 5,000? 30,000? He wants to live large. 5,000? You think you can make it off 5,000? Housing's pretty expensive. Medical bills, vacations. You know, life gets more expensive when you don't go to work because then you have all this free time. So then you want to go out and do things, and you know, things cost money. You want to go up a little more? 10,000? All right, $10,000 a month. So how much do you have to invest to get $10,000 per month? Interest. How much do you have to invest with this sort of investment plan in mind in order for you to get $10,000 per month? We have to be careful that this is per month, right? And this equation was all talking about annual, right? This is an annual return. This is $217 earned in an entire year, not per month. So if you want it per month, you're going to have to multiply it by 12. So that means we need $120,000 per year in interest. Okay? So that's the setup we have to have. $120,000 is equal to 0.434y. If we wanted to get $10,000 in return, we need $120,000 per year. So we set it equal to g of y. We solve for y. We see that for y we need $276,497.70. And for x, which is 3 times as much, we would need $829,493.09 cents. For a total investment of $1,105,990.79. Okay, so like if you save up to that, you ready to retire? Everything be okay? $10,000 a month? What's some problems in that idea? Some things you can think of. Okay, for one thing, inflation, right? As time goes by, things get more and more expensive. And if you get your fixed, $10,000 a month, right now it buys a lot of stuff, but 20, 30, 40 years from now, it's not going to buy as much, right? Think about 40 years ago. 40 years ago, you can go to McDonald's and buy a whole meal with like $1. You get change back. Movies were, you know, a few dollars, $2 to go to the movies. So now things are way more expensive, right? So in the future, it's probably going to cost you like $100 per movie ticket to go to the movies. McDonald's will be like $50 for a meal plan. They like the cheapest. They'll have the $100 menu. Hey, it's the $100 menu. So cheap, right? So things are going to get expensive. You know, houses are going to get into the billions of dollars. This is a $1 billion house right here. Good luck buying it. So that's one thing. What's another concern you might have? This is your plan. Other than inflation. Are you really going to get to keep this? Who's going to want to share? Government, right? We got to pay taxes on this, right? So you pay taxes when you collect it, and then your money makes interest, and then you pay taxes again. So some people don't think that that's fair. That sounds like a rich person problem, right?
You might not have enough to start with.
What's that?
You might not have enough to start with.
Well, yeah, I mean, assuming that you can even get to the $1,105,000 in savings, or let's say you won it in the lottery or something, you just, boom, you won all that money, you know, invested. But even if you won it, of course, Uncle Sam's going to want his share of that part too, so they're going to want a slice of that, and then they're going to want a slice of the interest you earned from your investment, so got to be careful. All right.